Okay, this is the traffic light one for B. So I was just asked if they have sensors in the road. Yes, they do. I've actually designed one. It was awesome. Very cool. Okay, the only downside, the motion sensors are better.
I thought it was weight sensors.
In a sense, like the motion sensors you see up top on the lights, I think those are better, especially if you're in a smaller vehicle. Because the weight sensors, it's a weight plate in the road. So when I ride my motorcycle and there's a weight sensor inside the road, I don't weigh enough to get the light to change. Okay, I do. So I like watch traffic, or if there's one in particular up and down the Gordo when you hit 82 and 54. So when I'm coming off of 82 trying to get on to 54, I don't weigh enough. So I will literally scoot the whole way up to the left in the median, and then I wave at the person behind me like, hey, come be my friend, because your vehicle weighs more than mine. Yeah, sometimes our cops will sit there and watch me.
Right?
Sometimes they will. So I'm just playing by the rules.
Tell them if it's the light.
So how could you tell if there's a sensor or not a sensor?
Usually you'll see the hexagon cut out in the road.
Yep.
Where your car's sitting. Because it has to be able to flex with the weight. Yeah. It's kind of cool. Okay, so it says in Britain a yellow light. Yellow light simulating by having both red and green lights on at the same time. The simulated yellow light occurs both at the beginning and end of a green light. If the car one means the car is waiting to go. Okay, so yeah. Okay. Let's see if we can make this happen. Maybe, maybe not. Okay, somebody tell me how this works.
Okay. So whenever there's a car, it goes through the system. If there's not a car, it stays red.
So you're saying that, okay, so it says car input equals 1 means the car is waiting to go. Okay, so this is an actual traffic light for you in your vehicle, not for you waiting to walk over to Starbucks on University. Okay?
Chick-fil-A.
Chick-fil-A. So this means car waiting. And if you need to write notes on the test, like I don't remember what this means, write notes on the test. This means the car's waiting. So let's see. SO, red equals 1, green equals 0. So this must be that we have a red light here, right?
Yes.
Okay. Car's waiting. So we have car going. Is this an active low? Having both red output and green output lights on at the same time.
That just means it shows that it's yellow.
Okay. So this is yellow. Right?
So
This is green.
So do you go or do you wait?
Okay. Ha ha ha. Okay.
You just slowly start.
And then you have yellow again?
Car waiting. I think this might be an active low.
So there's two.
But how do you know?
Just because, okay, so we've hit reset, right? If car is 0 means there's no car. Okay, there's no car waiting.
Stays
We're
red.
red. Okay. But then car 1 means the car's waiting, and then it goes to yellow. And then we go to green, and then we go to yellow, and then we go to red. But we have red when there's no car waiting.
No, in other words, as in car, like, whenever there's a car actually there, then it's gonna turn green. When there's not a car there, it's just gonna stay red. So waiting kind of throws you off, but like,
Yeah,
just
that
car
waiting does
is-
kind of throw me off. Any other insights to why she might be right or wrong?
Why would you have yellow before green?
Because it cycles through. It's gonna do yellow before you go to green, then you're gonna go to yellow, and then you're gonna go back to yellow.
So do you go?
It's British,
Do
okay?
you go
It's
on
British.
yellow, or do you slowly go on yellow? Or
You could like creep. We're gonna say you could creep on yellow.
Like you just barely start going until it's green.
Yeah. Creeping.
What the heck?
So let's see. In Britain, a yellow light is similar to both red, output, and green. Okay, so it says simulated yellow occurs at both the beginning and end of a green light. The car input equals 1, meaning the car is waiting to go. Waiting to go. Waiting to go. All right, that's cool. Okay. I like this. I like this. It makes more sense now. The more you read the question, the more it's going to make sense. Okay, but if you're trying to do one of these problems and you haven't read the question, you're not going to get the question right. Read your question. Okay, cool. I like this. I like this my mojo. So we could write an entity in our architecture for this, right? It wouldn't be hard to do. Okay. Are you saying okay like as in yes or okay as in right like right? All right, so let's write some sample code of this. Why not? So I didn't really need this. Okay, so this whole thing is the entity, right? Entity writ light or backwardsness is, okay, we have a port.
Res.
We want res, clock, what else?
Clock?
Clock or car?
Clock.
Clock.
Where it just doesn't show us where the clock goes, right?
Well, I mean the clock's implied, isn't it? Isn't it?
Oh well, yeah, because on the Chick-fil-A one it like waited 5 seconds and then 10 seconds.
Yeah, because we're gonna have a delay between them, right? It's not gonna be, okay, if you were sitting at the light and it went like, it was red, yellow, green, red, I'd be like, oh, man, I don't like it. Right, so we have to have clock to give us some simulation of time, because we were gonna run through them, it's not gonna be instantaneous, right?
So then if there was a traffic light that actually did that in real life, would the clock be messed up or would it be the cycles that are messed up?
It would be, well, if it did that in real life and went that fast, and it's dependent on a clock, it would be the clock's messed up. It would be like microseconds. And then you'd have some really angry drivers.
Yeah, because I was thinking about back home, like when they flash like that, it's
Mhm.
just freaking annoying. So the clock, they need to fix the clock.
Okay, so we have clock, we have reset, and we have another input, right? Car,
Mm-hmm.
okay, and this is in, and this is STD logic. Just regular logic, right?
Yes.
Then we have outputs, correct?
Mm-hmm.
Which are gonna be R and G, right? Outs, the little quotation marks means I'm just copying what's above it, okay, because I'm being lazy. And then we end it, right? So we called this whole thing, we said these are inputs, these are outputs, awesome. Now you gotta tell me how it works. No weakness, my greatest weakness is the semicolon.
I mean, he took off points.
He does take off points. That's my bad.
So
I have lost a
architecture.
point.
Architecture grid light is
Process.
Is
Okay. Is process,
Red box.
process, state.
so we do processes with the state maps.
Mm-hmm. State and card, right?
I thought we had to process the clock first. On the right.
Isn't res a hierarchy though?
We don't have, so it's gonna be next state and card because it's card dependent. Cause if reset's pressed, great, but if we have card that's not changing, we will never change states.
So
It's card
most
and
important
state
thing.
dependent.
So which one's the okay?
So it would be car is our highest, and then state is our next.
So, when, car.
When we're in S0, when S0, right,
If
is equal
car
to if car
equals
equals 1, then
next thing,
and state equals
S1.
S1, right? Semicolon, okay?
Would you have to edge?
Else,
Okay.
right? So if we're in state S0 and car is 1, then we move to next state.
The next state would be
Okay.
S1.
It'll be S1. Okay. If we're in S0 and car is 0, which is the only other state we can be in, we stay. So next state equals S0. S state equals S0.
And then it's one quotation
Right.
mark. Oh, shoot. Just kidding.
Because it's saying that when we're in S0, we have 2 conditions. Okay? If we're in S0 and car is equal to 0, we stay in S0. If we're in S0 and car equals 1, then we can move. 2 conditions on state of S0. This is exactly what that's saying.
So then like the else is basically like when it's 0.
Yep. Else, because there's only 2 states.
Mhm.
So we can have car or we cannot have car. So that else takes care of that secondary state.
On that last else, could you also say next state is state?
I wouldn't.
Wouldn't you say?
I would deliberately stay next state stays the same state.
Else. So you need a else when or like what?
Not
Wouldn't we have and if? And if?
this is gonna because this is the if, this is the end if. I'm gonna stick this over here. Literally, you can write this out in one big long line if you really wanted to. But this looks nice.
Would be so bad.
Okay? Because if I had to track this in one line, I would not be impressed. But I kind of would be at the same time. Like, you get it that you can put it in one long, gross line. But this looks nice. Not that my handwriting's nice, but this looks nice on the computer. How about that? Okay, so we started a when, we did an if, we ended our if, we're still in the whens.
So then we do
So
an S1.
When S1.
When,
We do another one?
S1, right? Then we're end state.
Then it'll be S2.
Okay.
So we have to write another one. It's not all in
Mhm.
one.
You have to make a one.
So you have to do, when it's this, we do this. When it's this, we do that. When it's this, we do the next part. When S2, we go to S3. When S3, then we go to S naught. Then you have to do your others, right? Just in case, even though when we only have 2 inputs, we only have 4 states, I would also just kind of put in when others, just to cover your bottom.
And when others always.
So like, if we had 5 states, right? If we had 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, what is this? 4 and 5, okay? These are as many states as we have, right? We're gonna have bubbles 0 through 5. Okay, so we technically have 6 states, because we include 0 as that. But I can still go 1, 1, 0, 1, 1, 1, right? 5, 6, 7, 8. So I still have these 2 states we haven't accounted for. So what happens if we shock the circuit, right? And it goes from like this guy to this guy.
It doesn't have
It
anything for that, so it
fits.
wouldn't know what to do.
So it's like, oh my god, I don't know what I am. I don't know what I am. I don't know what I am. I don't know what I am.
So would you want it to restart?
So this is where your when others comes in, okay? So if you're not any one of these 6 and you become one of these other 2, that's when we say when others, we want to go back to 0, 0.
So like when the power goes out, is that
When the power goes out. It's a good, that's a really good one. Like power surge, power loss, yes. So if you had messed up your circuit and had somehow found its way into one of these states, then you have a condition for it. When we're one of these, don't worry, we know what to do. We need to go back to the beginning. Does that make sense? Okay, so these are the whens. We're gonna come all the way down to when S3, blah, blah, blah. Then we go to S0, right? Okay, then you need to do your conditional statements for R and G. Okay, so yes, you're gonna end process, E and D process. Then we want to do your condition for R.
Don't we
So
have end case 2 before end process?
we do have to end the case first. End KC. This is why y'all are taking the test and I am not.
State.
Oh, that's what I was asking. Then isn't there a time where we list all of the states?
There is, but I think that
Processes?
because we're gonna call out those two. So it's state and next state. You're gonna have to double check and consult your notes. That's a very good question for Dr. Burke.
Which one? What is
That one for calling out the state, next state ones.
Well, it depends what the question is asking you.
Yeah, it depends on what the question's asking you as well. Okay, but the last thing we have to do is between R and G. So, right, so when R is 0, right, when
State equals
next state, or when state equals S2,
else.
okay? Because this is only gonna be 0 at state 2, so else it's 1. Oh, yeah, like that. Semicolon. This is a single quote. And then G is going to be 0 for which state?
Every
On state. State S0 else 1. Right? Semicolon and however many entries. Okay? I know that this is a little bit sloppy, but it gets the job done.
Yep.
Okay? For that one, I suggest you consult your notes.
Well, he's gonna give us that like to follow.
He's gonna give you it to follow, but you should also look at your notes just to make sure you have it together. And that's all I've got. I have got to go. Okay? I will try to put these videos up